Okay, let's just look at an argument here. Now I'm going to show that if 2047 isn't prime, then it's divisible by something that's less than 47. Okay? So, 2047 is prime or divisible by something which is less than 47. Now, the fact that I've got 47 here and 47 here makes no difference at all. This is the first of the 2 to the n minus 1 numbers that isn't prime when n is prime. It's the first potential Mersenne prime that doesn't work. And there were a lot of people who believed, just kind of on faith, that Mersenne primes, or that any time this number was prime, this number had to be prime. There were people for a long number of years, back before the 1500s, who just believed that based on faith, and I don't think anybody really tried hard to test it until around that time. Okay, now the reason the 47 is here is not because there's a 47 here, but because, just note this off to the side, 43 is the next prime less than 47, and it turns out that 43 squared is going to be what? That's going to be 1600 plus 480. I can amend this. I was thinking that 43 squared was bigger than never mind. Okay, 18 something. That's 1849, I think. And that's less than 2047. 47 squared, on the other hand, is 2191, which is greater than 2047. Now that's how I know that there has to be a number less than 47 that divides 2047. Okay, the reason is this is less than 47 squared, so that 2047 divided by 47 has to be less than 47. Now, if the smallest divisor of 2047 is not less than 47, so if the smallest divisor is greater than 47, then and let's amend this, smallest proper divisor, then 2047 has two divisors, both greater than 47. But 47 times 47 is equal to 2047. So something up to 47, and really the last number we'd have to divide by would be 43. If we get all the way up to 43 in dividing 2047 and don't come out with an even result, then we've proved that it's prime. So if some prime less than 43, bad quantifier here, if no prime less than 43 divides 2047, 2047 must be prime. Now your book talks about the fact that if you're checking a number for primeness, you only have to divide by numbers up to its square root. And if you think about it, the sieve of Eratosthenes shows this also. If you had crossed out, or once you've crossed out all the primes up through, crossed out the multiples of all numbers up through 43, assuming your list goes up as high as 2047, then the next non-prime number on that list will have to be at least as big as the next prime squared. Well, the next prime after 43 is 47, so the next prime would have to be bigger than 47 squared, which is bigger than 2047. Or the next number to be crossed out, the next non-prime number, would have to be bigger than 47 squared, which is bigger than 2047. So the sieve can also be used as an image to argue this. Now the point is that you can divide by all the prime numbers up to 43. You can probably do that in about 3 minutes if you're pretty quick with your calculator and have a list of the primes or know what the primes are. And you can find what number goes into 2047, and you can rediscover something that wasn't discovered for many, many years until the 1500s.